Good morning, students. So in our last class we discussed about the increasing and decreasing. Mainly there are four parts, four topic we get: strictly increasing, increasing, strictly decreasing and decreasing. And with respect to these four we get four conditions there, is not it? So now here if you see the conditions again one more time, if you see mainly the graph here, suppose two coordinates are, we get one coordinate is here, which one is we consider x1, and another coordinate is here, we consider suppose x2. So in this case the graph if suppose increase, now here this one is the length of y, is not it? If the graph we consider y equal to fx, if the graph we consider y equal to fx here, in this case this one is f of x1 as well as this one is known as f of x2. In our last class we discussed about this, so that's why here we get f of x1 and this one is we get here f of x2, is not it? So now in this case if we see here in between these two which coordinate is greater, so obviously the x2 is greater here. So each and every case this one we get x2 is greater than x1, that means the coordinate x2 is greater than x1 here we get here, which gives us the, since the curve increase here, so that means in this case which length is greater here, obviously f of x2 is greater. So in this case we have to write this one is f of x2 is greater than f of x1. So this one is the condition of strictly increasing, is not it? So this one is the condition of strictly increasing. And at the same time one more condition we get, which one is, so you see here x2 is if suppose greater than x1, this gives us, so if we get this condition x2 is greater than equals to f of x1, then this one is the condition of what? So this one is the condition of only increasing, because here greater than equal to. So here the question is arise, how which type of diagram if we draw we get greater than equals to. If you see this one mainly, suppose this one is the xy plane here, again if you consider one graph here like in this way, lying in this way, if you see, or you can choose another diagram here, suppose in this way also you mention here. If suppose you see in this place the graph in equal here, at this place increase, again equal, again increase, so this type of, no doubt here each and every time increase as well as equal also. So that's why in this type of diagram we get here greater than equals to. Is it clear? So these two are the conditions of strictly increasing and increasing. And with respect to this, with our theorem here, one theorem also we get here. With respect to this theorem, the condition is what? If f dash of their derivative, if f dash of x is greater than 0, then it is known as strictly increasing. One more condition. So here one condition is this one. With respect to this also we can prove another condition is what? If f dash of x is greater than 0, then it is strictly increasing. Or if we write here f dash of x less than greater than equals to 0, then also we can say here it is only increasing. Is it clear? This one another condition we get here. After derivative we can prove like in this way. Is it clear? Two conditions are here, another one is this one. Strictly increasing, f dash of x greater than 0 is strictly increasing, and here increasing and f dash of x greater than equals to, then it is increasing. Is it clear? So in the same way here we get another two conditions. These two conditions are for decreasing and strictly decreasing. So the first coordinates are obviously x2 is greater than x1, but the graph decrease here. So in this case what we get here, the value of f of x2 is less than f of x1. In our last class we discussed about this, and in this case what we get, f of x2 is less than equals to f of x1 we get. So these all these things are about increasing and decreasing, isn't it? So with respect to this we also discussed the wavy curve method, and there are some conditions are also we get how to find out the coordinates or how to find out the intervals. Actually interval ami keneke find out karim tar upor ami discuss korisilu, isn't it? So now among all these things, now today we have to start our exercise, and the exercise is 6.2, and this 6.2 exercise is very important from examination point of view. So that's why here one by one each and every question we have to do here. Is it clear? So let's see here how can we do these questions. So in exercise 6.2, if you see the first question here, the first question is given what? So that the function given by fx equal to 3x plus 17 is strictly increasing on r. R means what? The real number. is not it? So that means here the function is given fx. If you see here, fx equal to 3x plus 17, and we need to prove this one is strictly increasing. So here two conditions are there. Either we can prove f dash of x greater than 0 in case of real number, or the second method also, x2 is greater than x1, or f of x2 is greater than f of x1 also we can prove. So in both ways we can solve here. Is it clear? So first of all, if you see here what we have to do, so in this case now here the given function, so the function given here fx equal to how much given here? Thrice x plus 17, and where x belongs to R. Already mentioned this one, is not it? Fx equals to 3x plus 17 is strictly increasing on R, we need to prove. So that's why if you see the first method here, so now in the first method, strictly increasing condition is what? F dash of x is greater than 0. So that's why what you have to do, we have to differentiate this one with respect to x. So if we differentiate this one with respect to x, so that's why what we get here, f dash of x. If you differentiate this one, then what we get? Simply here ddx of thrice x. So ddx of thrice x, 3 constant term come outside, ddx of x is 1, is not it? So that's why here simply remain 3, and here it is 17, ddx of constant term equal to what? 0. So that's why here no need to write this one. So simply f dash of x equal to what we get here? 3. So now here 3 is a real number, and which one is obviously greater than 0, is not it? So from here what we can say, so from here we can say f dash of x is greater than 0. Is it clear? So if f dash of x is greater than 0, it is the condition of strictly increasing or not? F dash of x is greater than 0, that means from here what we can say, it is strictly increasing. So simply here we have to write, therefore we can write here fx is strictly, therefore fx is strictly increasing on R. Is it clear? So in this way we can complete this question. Is it clear? Fx is strictly increasing on R because of f dash of x is greater than 0. Is it clear? So very simple question here. So this one is the first method. Is it clear? Okay, now we apply the second method. How can we prove? Through second method. So again here if you see, we consider the function fx equal to thrice x plus 17 here. Now again we have to apply the second method. For this what we need? So we need two coordinates, is not it? Because the second condition is what? x2 is greater than x1, which implies f of x2 is greater than f of x1, is not it? This one is the condition of strictly increasing. So that's why here two coordinates or 2 points are we need, which two are we consider from axis. So that's why we have to consider here, let x1 comma x2 belongs to R. That means two real numbers we consider here. So here x1, then after that x1 we get x2. So that means from here easily we can say x2 is greater than x1. So here what you have to do, now if you see here, now if we write down the first condition, whatever we write at starting, so we write here now x2 is greater than x1. x2 is greater than x1 we write here. So in this case if you see here, now the function is whatever given, so we have to rearrange this result like in this way. In this form we have to arrange this result. Is it clear? So here x2 is greater than x1, but we have to arrange the result in this form. So if we arrange this result in this form, so how can we arrange this one? You see here x2 x1 is there. So first of all, to arrange this result, so with x how much we have to multiply? 3, isn't it? So that's why multiplying both sides by 3 now here. So if you multiply both sides by 3, then we get here 3x2 is greater than 3x1. Anything is changed here? No, because in case of inequality easily we can multiply the real number, positive real number in both sides. If we multiply negative number, then the sign will be changed here, is not it? So that's why here positive number, so that's why simply we multiply. So that's why we get here 3x2 is greater than 3x1. Is it clear? So now after that if you see, after multiplying 3, how much we need here? 17. So in case of inequality also we can add also. So here what we have to write? 3x2 plus 17 greater than this one we have to write 3x1 plus 17. Adding both sides by 7 here. 17, sorry, adding both sides by 17 here. So if you add 17 on both sides, then again the result will remain same. Is it clear? So now here, after writing this one, you see here, when it is 3x plus 17, then we write down the function is fx. If you see here, 3x plus 17, when we write, then it is fx. So if it is z, 3z plus 17, then what you have to write? F of z. That means this one we can say function of x, function of z, function of y, whatever they are given. So in this case, you see the result 3x2 plus 17. So that means it is the function of x2 or not. So that's why in this case, we have to write f of x2. Is it clear? And in this case, if you see here, this one is the function of x1, 3x1 plus 17. So that's why we have to write here f of x1. Is it clear? So now here function of x2, function of x1. So here this question is here fx equal to function of x. So that's why here written 3x plus 17. So at starting, what we consider, x2 is greater than x1, and finally what we get here, f of x2 is greater than f of x1. So this satisfies our which condition? Strictly increasing condition, isn't it? So that's why easily we can say yes, fx is what? Strictly increasing on R. So therefore finally here the conclusion what you have to write, therefore fx is strictly increasing on R. Is it clear? So this one we have to write here, and then our solution is complete here. So this one is the second method. I think all of you understood this one. Is it clear? Okay. I think the first method is more comfortable than the second method, isn't it? So in first method, what you have to do, just we have to define set, and let's check out whether the result positive or negative. If negative, decreasing. If equal to sign also given, then strictly increasing or increasing, whatever we get here. So after that, now here in the first question we use both method. So from the second, third or fourth, whatever the questions given here, so in this case we have to apply the first method, or if you want you can apply the second method also. Is it clear? So now here, after that, now if you see the second question here, the second question is given again. What we need to prove here? We need to prove strictly increasing on R, and in this case the function is given fx equal to e to the power twice x. Is it clear? So fx equal to e to the power twice x is given here, and we need to prove this one is strictly increasing. So again we have to write here, if you see here, this one is given. So given that fx, so fx equal to, here given this one is e to the power twice x. So fx equal to e to the power twice x given. So what you have to do, we have to define set this one with respect to x. So that's why f dash of x. So now all of you know the formula of this result. So it is of the form, if you see the formula here, ddx of this one is e to the power mx. E means exponential, isn't it? So ddx of e to the power mx form. So ddx of e to the power mx, there is a definite formula for this result, e to the power mx. So e to the power mx means what we get, the formula we get m into e to the power mx. This one is the formula. So ddx of e to the power mx means m into e to the power mx, which one we get in derivative part, is not it? So now in this case you see here m means what? 2. So if m is 2 here, so easily we can apply this formula. So if we apply this formula here, then what you have to write? 2 into e to the power twice x. So we have to write here 2 into e to the power twice x formula we can write here. Is it clear? So according to this, here m means 2, so that's why we have to write 2 into e to the power twice x. So now f dash of x is greater than 0, here we get. So here x means what? Here x means any real number. Any real number means it may be positive or negative, whatever we write. So if you put any value in place of x, now here, if you put positive value, then obviously the whole result is what? Positive, is not it? So if you put 0 also in place of x, if you put 0, e to the power 2 into 0, that means e to the power 0. So what is the value of e to the power 0? The e to the power 0 value is 1, isn't it? So now here again a positive value we get here. So if we put negative value, x is negative, suppose minus 1. So minus 1 into 2, e to the power minus 2. E to the power minus 2 means also we can write 1 by e square. So 1 by e square is again a positive value or not? So ultimately again we get a positive value. So if we put here whether positive value, negative value or including 0, each and every time we get a positive value. That means which one is greater than 0. So that's what we can directly write here, it is greater than 0. Is it clear? So therefore the conclusion here, what you have to write, fx is strictly increasing on R. Is it clear? Fx is strictly increasing on R. I think all of you understood this one, so no need to do anything here, just you have to check out whether it is greater than or less than, and then simply we have to put here. Is it clear? Now after completing the question number 2, now again here the third question is, if you see fx equal to sin x is given, fx equal to sin x, that means this one is a trigonometric function, and this trigonometric function here 3 conditions are mainly given. So if you see the question here, the question is given like in this way here, fx equal to sin x, whatever the function given, we need to prove here first of all in between 0 to pi by 2, in between 0 to pi by 2 it is strictly increasing, and in between pi by 2 to pi it is strictly decreasing, if you see the question here given, and the last one is given here neither increasing nor decreasing. In which interval? From 0 to pi. Is it clear? So simply if you see here one diagram, if you see here first of all this one, first quadrant, second quadrant, third quadrant, fourth quadrant. In first quadrant all are positive, isn't it? So in this case all are positive, here only sin and cosec positive, tan positive, cos positive. So ASTC rule, so this rule is very important here, isn't it? So this rule we have to apply here. Is it clear? So now let's see how can we do this one. So first of all, whatever the function given here fx, so first of all we have to write this one. So given fx equals to first of all we have to write sin x. So this one with the help of derivative we have to prove this one, and here what given, x is a real number, or the intervals are already mentioned here from 0 to pi by 2, pi by 2 to pi, and finally the last one is from 0 to pi, isn't it? So now first of all we have to differentiate this result. So if you differentiate this one f dash of x, so therefore if we differentiate this one f dash of x, so f dash of x equal to ddx of sin x is what here? So ddx of sin x means here it is cos x. All of we know this one? No or not? So ddx of sin x is cos x. So simply we have to write f dash of x equal to cos x. Now here after getting this one, now we have to check out the interval here. The first one is given here. What we need to prove in the first question, we need to prove fx is strictly increasing in 0 to pi by 2. Strictly increasing in 0 to pi by 2. The first condition is given here. We need to prove. In interval, in which interval we need to prove here? 0 to pi by 2. 0 to pi by 2. So now in this case if you see the graph again, so here this one is x, here it is x dash, this one is y, and here it is y dash. So the interval is given from where to where? 0 to pi by 2. And one more thing, if you see here 0 and pi by 2 is not included, which one we get in class 11. This one is an open interval or not? Open interval, that means 0 and pi by 2 not included. So in between 0 and pi by 2 if we put any value, that means which quadrant? Obviously this quadrant. 0 to pi by 2 means this quadrant. So here all are positive. Here all are positive or not? In between 0 to pi by 2 here all are positive, because here pi by 2 not included and 0 is also not included. So in between values are we have to consider like 30, 35, 40, 45 or whatever we get here. So if in this case all are positive, so that means from here what we can say? So what we can say here? F dash of x. So f dash of x, simply we can directly say here f dash of x is cos x, and in the interval 0 to pi by 2 here all are positive, so that's why we can say here this one is greater than 0. Is it clear? So this one we can say here greater than 0. I think all of you understood this one. Why? Because the interval is given from 0 to pi by 2. So if the interval is from 0 to pi by 2, 0 and pi by 2 not included, so that's why we can say the f dash of x, the whatever the value f dash of x cos x, the cos x value is always here positive. That means which one is greater than 0. So from here what we can say? Therefore fx is strictly increasing. Therefore the function fx is strictly increasing in which interval? In 0 to pi by 2. Is it clear? I think all of you understood this one. Okay, now after doing this one, now the next one is here, the second one is given from which from interval pi by 2 to pi, isn't it? So the second interval is given here from in, so the second one is from pi by 2 up to pi. So in this case again if we see the axis. So here x, so this one is x dash, so here it is y, and this one we write here y dash. So the interval is again, you see, open interval. If it is open interval from pi by 2 to pi, so at this place pi by 2 and at this place it is pi, so pi by 2 and pi not included. So in between these two we have to write down the angles in between pi by 2 and pi. So in this case, if you see here the f dash of x, so f dash of x value is cos x, is not it? So in this case, any value if we get in second quadrant of cos x, so in this case cos is what here? In second quadrant only sign is positive here, but we get after define setting we get f dash of x equal to cos x. So if we consider cos x on second quadrant from pi by 2 to pi, in this case cos x is what here? Any value if we put here, then obviously the cos x value is here negative. So if it is negative, so that's why we have to write it is less than 0. Is it clear? In second quadrant cos negative, so f dash of x value is, cos value is negative. So from here what we can say? So we can say here f dash of x is less than 0. In which interval? From pi by 2 to pi. Is it clear? From pi by 2 to pi, the cos x value is 0, less than 0, so that's why f dash of x is less than 0. So if f dash of x is less than 0, then what we can say here? The function fx is strictly decreasing in which interval? From pi by 2 to pi. Is it clear? Okay, now after getting these two, 1 and 2, now if you see here, in first interval we get strictly increasing, and in the second interval we get strictly decreasing. For third one is given for 0 to pi. So in third one from 0 to pi. So here from the first two easily we can say the third result, the conclusion. So x dash, here it is y, this one is y dash. Is it clear? So in this case you see here from 0 to pi by 2 it is increasing, and from pi by 2 to pi it is decreasing. In this case you see here we have to check out the interval from 0 to pi. So at this place it is 0, from here it is pi. So in this case you see here from here to here increase, and then this one is what? Here decrease, like in this way decreasing, strictly decreasing. So now in this case if you see check out the whole result here from 0 to pi. If we check out the whole result from 0 to pi, then it is what? If we check out the whole result here from 0 to pi, then in this case what we get? Neither increasing nor decreasing. Reason behind, if you see here. And one more thing, if you see, when we consider a graph always we consider from the left hand side. So that means if the graph moves like in this way, then it is increase. If graph move from the left hand side like in this way, then it is decrease. Is it clear? So don't confuse here. You see here the graph moves from here, not from here. If it moves from here, then it is decrease, but the graph moves from here. Clear? So এই গ্রাফটোকে তুমি উল্টাই দিলে হল, এটো যদি এনেকে উল্টাই দিলে ডাইরেকশনটো কেনকা হ'ব? এটো হ'ব নাই. So that's why it is increasing and it is decreasing, because the interval is given from 0 to pi by 2, and second one is mentioned from pi by 2 to pi, not from pi to pi by 2, or not from pi by 2 to 0. Is it clear? So in this case increasing and decreasing both conditions are on the same graph. So it is not possible increasing but decreasing hobole hole either increase hobo laibo নহলে decrease hobo laibo. Jodi duita condition jodi ekeloge thake titiale AOD I think lecture 2 or 3 number lecture gitat ami neither increasing nor decreasing ketia hoy ami ta discuss korisilo. Is not it? So the same condition here we get, in this case increasing as well as decreasing, both conditions are there. So that's why from these two what we can say, in interval 0 to pi the function fx equal to sin x is what? Neither increasing nor decreasing. Is it clear? I think all of you understood this one. So here today we complete 3 questions. So in our next class we have to continue this exercise. So I think all of you understood this one, and if any queries or any doubts are there, then you can ask me. Is it clear? Okay, thank you.